Hi students, in this video we'll go over how to name oxyacids. It's assuming that you've already covered the videos on binary acids and also polyatomic ions. The focus is strictly oxyacids here. So citrus fruit has citric acid. And like in earlier videos, we talked about how this functional group is referred to as a carboxylic acid group or a carboxylate group. We looked at acetic acid, and you notice it has this carboxylic acid group. And this is the hydrogen that will be dissociated and released as a proton, leaving behind what's referred to as the acetate ion. So acetate. Okay, so acetic acid, when it does its job and dissociates a proton, it leaves behind the acetate ion, which is an oxyanion, which is what the polyatomic video talked about. And then that's just a binary acid. So I put that to show you that this is not an oxyacid. Why? There's no oxygen in it. It's just two elements. It's binary. So its name is going to follow that hydro prefix and ic acid suffix. So again, the polyatomics, those are ions with two or more atoms that are bound covalently that carry a charge. And we reviewed that last time. So I told you I really want you to know the 5 big 8s, and carbonate was one of them. Carbonate is not on the 4 in that corner in that video that I talked about, so it only has 3 oxygen. But we also, if we learn those 5 big 8s, see that, well, then hydrogen carbonate is like carbonate. It just has a hydrogen, a proton attached to it. So we've already talked about these. We talked about the 2-member families and the 4-member families in the previous video. And why is that important? Well, we're going to use the oxyanions to help derive the oxyacid names. So the oxyanions, there were the 2 families that we talked about. There's either the 2 or the 4 members. So we had the ite and the 8 families. So that was the 2-member. Or we had the hypoite, ite, 8, and per 8, which were the 4-member families. So what do we do for the oxyacids? The name of the oxyacids basically is derived from the 8 ion. So the ic acid come and gives us the 8 ion. So what would be an example? I didn't write this, so I apologize. So this is nitric. So I take the base name of the nitrogen, nit, and I add the ic acid suffix, nitric acid. If I throw this in water, it's going to dissociate that proton. How do I know it's an acid? It's got the hydrogen written in front. How do I know that this isn't binary? Well, there's more than 2 elements. That's why there's no hydro prefix. So this is an oxyacid because there's oxygen. So the ic acid, when it dissociates and gives me a proton, it gives me those 5 big non-metal 8s that we were talking about. So the ic acid gives me the 8 ion, and in this case, that would be nitrate. Well, it's the same thing with the ites, right? But instead of the ite giving me an ic acid, it gives me an us. Remember that those 2 suffixes from the transition metals, the ic and the us is less, 1 less. So HNO2 is 1 less than HNO3. So this isn't nitric acid, it's nitrous acid because it's less. Us goes with us. If I throw this in water, it's going to dissociate, give a proton, and actually I should have a double arrow here because it's a weak acid and only partially dissociates, so it's in a state of equilibrium. We'll get into that in later discussions. But for now, if a proton is dissociated, I'd be left with this oxyanion, that polyatomic ion. And that is one less than the 5 big nonmetal 8s that I told you. So this is nitrite. So it all builds, all of this naming builds, it makes sense. If you build on that 4 on the periodic table to determine the 5 big nonmetal 8s, the rest of this gets a little bit easier. I mean, it's going to take work, but at least you have a foundation to build on. So as you can see, the 8 derives the ic acids. So nitric acid, sulfuric acid, chloric, perchloric, carbonic, phosphoric. Where are those names derived? They're all ic acids. They're all derived from the 8 ions. So this right here would be nitrate. This right here would be sulfate. That right here would be chlorate. That right there would be, and the charge matches the number of hydrogens. That would be perchlorate. So carbonic acid has 2 hydrogens. Why? Carbonate has a -2 charge, right? So if I have H plus and carbonate, which is a 2 minus, and I crisscross, what do I get? H2CO3. Same here, phosphate, 3 minus. Hydrogen, +1. If I crisscross, what do I get? H3PO4. And the 8 ion is derived from the ic acid. So this is phosphoric acid. Why? Because this is phosphate. Oh, by the way, this is a diprotic right here. This is a diprotic. This is a triprotic acid. Why is it triprotic? There's 3 possible protons. Now the ites give us the us acids, right? So this is nitrite. It's got a -1 charge, so nitrous acid has 1 proton. Chlorite, so chlorous acid. Hypochlorite, so hypochlorous acid. Sulfite, sulfurous acid. So that's basically how you name oxyacids. You use your oxyanions, the 8 and the ites, and the perates and the hypoites. I hope that makes sense, and thanks for tuning in.